physics video. Sort of a strange one. I'll play clips from, I think, various videos, and all on this general subject of the foundations of quantum mechanics, the foundational experiments that led to whatever, the conclusion that photons in particular, but they've included now electrons and atoms, don't have a fixed reality, and there's no determinism, there's no mechanical system that every moment is a new probability somehow. That they're not particles, that they're not a discrete bit in following a dictated path based on the few simple properties that these elemental bits have, especially the photon that I'll keep mentioning. Supposed to be, was in the old world, thought of as a real fundamental bit. You can't slice one into pieces, can't dissect it. It's just this little bit that moves in a straight line at the speed of light in a direction. That's it. Nothing, can't do anything else. Doesn't have any properties of its own through which to be caused to do something more elaborate or fancy. And that only through interacting with more complex arrangements of energy would it be capable of doing something interesting, different, changing, having its world changed. It's the ball in the pinball machine. Now, quantum mechanics says something quite different. It says the machine isn't a machine. The ball has somehow machine, the pinball machine, the bumpers and the things, somehow it has the properties of those things, and it reacts to the world because it has a complex structure of some kind, combining at least with this ethery thing it's traveling through, because it's not really a thing, it's some sort of element in a field of whatever, a field of whatever. So they didn't accept they didn't stay connected, grounded to that kind of understanding. They went with this more bizarre explanation for what happened. It wasn't the matter causing it, it wasn't structure causing it, it was something innate in these elemental bits that enable them to do strange things. They're waves in a medium of some kind, a completely undescribed mechanism, and they rejected the pinball machine for that based on these little experiments, and I would argue the experiments in themselves are easily explained in a mechanical pinball machine kind of way, for starters, and there's there's nothing innate in the phenomenon that's that challenging to say let's throw out the pinball machine metaphor and go with this this bizarre mysterious fog perception of reality. Well, anyway, so yeah, I might as well just get into it. And so this is mostly, and it starts with the two-slit experiment. That's what you keep hearing from all these people, the young thing, as if it was as if this was some surprise introduction to the notion that photons have that they're in combination with material interaction, that there's a phenomenon that isn't overtly obvious as to what happens, and that starts with Newton's rings. It starts with Newton playing with very small apertures and noticing that light spreads, and that it does so with a pattern, and that happened in 1650, let's say, And Young's experiment was in 1800. And in 1930, they somehow decided to find it too hard to explain and decided to go with this new explanation that photons don't have a place, that that frequency is energy, that these quantum mechanical explanations for things that are not that don't require it. But anyway, so this is a Yale professor. We'll do him first, I suppose, and then we'll go on to the PBS thing, and then we'll go on to the Jim, whatever his name is. These are just, I didn't select these videos. This is just the way they come. This is the way they treat the subject, and it's treated with a bunch of misinformation, incomplete information, just wrong information. And this is their foundational experiment. So, I won't play the whole video, but this professor at Yale just prefaced his remarks by explaining how this is the foundational experiment, and Richard Feynman said, and this is the one that has to be explained, and blah blah blah. And this is how he treats it so casually. The facts are just irrelevant to the mystique in the story, and that's certainly clear in many of the presentations. They cite experiments that variations on the two-slit experiment. They cite them as if they took place, and there were experiments that were never even done. That's how bad it is.
It's made up of these tiny little pixels which change color when light hits them, and then you see your picture. And that's the way to detect light. Perfectly good way to detect light. So first thing we do.
So he's just saying it's photographic plate, and they have two slits, and
we block this hole, or this slit. This is slit 1 and slit 2. We block this, and we look at what happened to the photographic plate. What you will find is that the region in front of it got pretty dark, or let's say had an image, whereas if you go too far from the slit, you don't see anything. So
right. So again, the same cliche misidentification of the truth. If you block one of the slits, then you have the single slit experiment, and with a wide aperture, you'll have a lot of pattern. So just a complete denial of what Newton discovered. So he has the diffraction in there, at least he's pointing out that the light spreads, but there's the divergence, but no concession that this phenomenon happens with one slit, that this exact same thing happens. You'll create an on and off pattern. So I mean, it's a fundamental aspect of this experiment, and it's just more attempts to just deny analyzing what's so special about the single slit. What's so special about a small aperture? Well, and I'd say the obvious thing that's special is that as you make the aperture smaller and smaller, the amount of light that's going to be hitting right near the surface increases as a percentage of the light that makes it through. So more and more light as a percentage is going to be very close to, travels very close to a surface. Now that should indicate something. Rationally, we could argue, well, maybe there's something on the surface. We've heard of these electrons, these free electrons. Maybe there's free electrons on the surface, and they're influencing the photons. Perfectly rational explanation, but no, forget about reason. Don't need it.
That's called intensity when one is open. Then you close that guy, then you get similar pattern. Then you
so, like I said, just a complete rejection of facts. No, we don't want to bother with those. We'll just describe it inaccurately because it's more conducive to the conclusions they've drawn, and that's all. They're just trying to support they're going with the wacky theory, and they're defending it by being dishonest to the evidence. They're just cheating the argument. Alright, this is the PBS guy.
Plus, One of the strangest experimental results ever observed has got to be that of the single particle double slit experiments. It's one of the most stunning illustrations of how the quantum world is very, very different from the large-scale world of our physical intuition.
So again, it's physical intuition. Now I could argue that our physical intuition wouldn't be too confused if I had the sun and the earth, let's say, and I was to speculate about moving a body through right between the two of them, just move it right between them in some location, either close to the earth or near the sun, doesn't really matter. And we thought of that as two slits, or even between Mars and the earth, and I was going to send an asteroid between Mars and the earth. You know, we'd be perfectly capable of understanding because of gravity. We would know that, well, if I send it through slow enough, depending on which planet it's closer to, it's going to get deflected in that direction. It's not going to get caught in an orbit or anything, but no, we could send it through and it'll be deflected by gravity. So we would understand it in a large-scale world. We could understand how the path of an asteroid would be changed by gravity. And so in the small-scale world, we know that the electric charge is the much more dominant force, the more dominant expression of gravity, if I can be allowed to say that, because it's polarized, and that's what charge is. But we know it exists. We know that charge exists. We know that electrons are, you know, owned by it, that they're part of the game being played. They're monopoles of the magnetic dipole, essentially. And then we know that if we sent an electron through two pieces of matter, we know they would have a charge, and we know the electron will tend to go based on the charge density between the two things. If one goes positive, one goes negative, the electron is likely to go towards the positive. Now, that's not, you don't have to be a nuclear physicist to kind of get that idea, that the same kind of thing will happen. The faster I send it through, the less it's going to get deflected. We know that with magnets. If I did that, if I had two magnets here and I threw a piece of metal through, that if I throw it slow, it'll jump right to one of the magnets. It'll stick. If I throw it a little faster, the faster I throw it, the more likely I am to get it through. And also the more likely it is to be bent in a direction. It's going to go in a direction. It's going to get pulled towards this one. As I throw it, it's going to start moving towards it, and it's going to be bent in a direction by magnetism. So we know gravity, electric charge, magnetism, all these forces will do exactly what is happening to photons in these experiments. We just don't know which one of those forces is doing it, but it's exactly the same thing that would happen just by speed changes. And yes, it'll come out. It'll be for sure the pattern will not have the bars in it necessarily with, say, gravity. It's not going to create a bar pattern because, you know, we don't have the instrumentality of frequency, you know, that is stuff coming at a set rate, and we don't have the fact that I have to complexify the experiment a little bit by pointing out that the photons aren't being bent by gravity. They're hitting electrons, and the electrons are deciding which way it goes, and the electrons move a specific way, and that's why there's places where there's a high density of likelihood to go and places where there's a low density. Is because of the position of the electron. But I'm just saying, you have the seeds of the explanation in the big world understanding of what gravity does to motion. And even though it doesn't explain it all, doesn't have the detail, it gives you the foundation for the explanation. You don't need to give the asteroid that you're throwing between the planets the properties. You can understand that the planets have properties. All right.
In fact, it hints that the fundamental nature of reality may not be physical at all, at least in any...
So this is the jump, the leap they take. You know, first they reject, kind of obstinately and on purpose, it seems, any mechanical explanation for any one of these experiments. It's like they avoid it. And you can see the aversion through the fact that they manipulate their description of the evidence to avoid the very bits of evidence that indicate what they're talking is nonsense or not true. So they have to distort what happens in the single slit experiment because it's not conducive to the argument they want to make. And so that clearly shows a bias towards this non-determined, we can't understand reality, it's mysterious kind of argument. It's clearly a bias because you can see it in their willful distortion of the historical record, their willful perversion of what the truth is, which is Newton discovered this phenomenon in 1650. And in 1930 they decided to panic and come up with a silly explanation for what's happening.
Sense that we're familiar with. Let's start with the familiar. In fact, let's start with a rubber ducky. It bobs up and down in a pool, causing periodic ripples to spread out. So this
is how we start off trying to talk about photons. So anything now that has a frequency, anything that comes at a frequency, is now waving, because everything has to be in a medium, and everything's some kind of movement in a medium. So again, this is just ether theory. So we've broken the idea of the universe being a pinball machine. Now it's some sort of wavy machine, and the ball isn't a ball, it's a vibration in the board of the pinball machine. No need to do any of that. And like I said, they're aggressively trying to do it by breaking an accurate description of the evidence that actually exists.
Distance away, those waves encounter a barrier with two gaps cut in it. Most of the wave is blocked, but ripples pass through the gaps. When the new ripples start to...
Right, so again, this is their convenient... He's not even going to go anywhere near the single slit, but again, just very convenient, because if it was a single slit, the same exact thing is going to happen in terms of a pattern, and yet by this illustration there would only be one wave going through the slit, and the one wave couldn't create that pattern. So their illustration can't be accurate because it doesn't account for the fact that a single slit will create the same phenomenon. And if a single slit creates this, then two slits should create two single slit interferences, which means there should be four interfering waves.
Overlap each other, they produce this really cool pattern. It's called an interference pattern.
Cool.
It's due to the fact that in some places the peak of the ripple from one gap stacks on top of the peak from the other gap.
Right, so again, it's just, this one just presumes wave. We won't even bother speculating about particles except when we want to demonstrate how they just go straight through or something, when we know that's not the truth.
Making a more extreme peak. You also get more extreme dips when two troughs overlap. We call this constructive interference. But when the peak from one wave encounters the trough from another, they cancel out, leaving nothing.
Yes, right, which any logical person knows that doesn't happen to photons. They don't disappear, they just go to a different position. They don't destructively interact with him, especially with themselves, because all of these waves are supposed to see. He introduced this as the single photon experiment, yet he's demonstrating it with the multiple photons first. But whatever. Alright, so this video is just so bad. So I probably won't get to the end of this video, so I just wanted to point out, at the end he does if we put a detector there and we try to detect the photons, well, we can't do that. So it's impossible to detect photons in a passive way. So of course you ruin the pattern by putting a detector there. But he actually pointed out how, well, if we unplug the detector, we get the pattern back. So if we're not watching what the detector is seeing, detecting, that somehow the pattern comes back. That experiment was never done. It's complete woo. And he's wearing a tuxedo and or at least a very nice suit, talking absolute shit.
I'm going to explain to you what's known as the central mystery of quantum mechanics. It was Richard Feynman, the American physicist, said, this is the central mystery of quantum mechanics. There's lots of weird stuff that goes on in the quantum world. Hit you with this, and
right, so again, this is where it all started, okay? So I would just say this is where physics put its head up its ass, was with this experiment, and then everything that followed just became a way of forcing everything else to match this. So then you end up with this de Broglie guy saying that the velocity of an electron, that is how fast it's going, is actually a frequency. So if it's going 10 miles an hour, it has a frequency of 10 hertz. So they made an electron into a waving thing. So it's like me saying the asteroid going between Mars and the Earth, and because I can come up with an equation about where it's going to go in some other experiment that has something to do with a frequency, I'll just do it to the asteroid. I'll just pretend the asteroid somehow is moving at a frequency when it's not, merely because the math will work out if I turn it into a frequency. If I turn it into a waving machine, then somehow the math will equate to the momentum, and I'll get the same answer. But it's just not the truth. The electron doesn't have a frequency. It's not that's not the way they fly. You can force electrons to have a frequency, but they have no native frequency. And again, their momentum is being converted into a frequency. So ironically, you could give an electron two frequencies. You could shoot them at a frequency, and then you can give them a momentum, and they'll essentially have both frequencies.
basically tells you what it's all about. It's called the two-slit experiment. I'll start with this. Imagine you have a source of light shining against a screen with two slits. Now, for the pedants in the audience, this source of light has to be monochromatic light, light of a particular wavelength. Well, whereas of course a light bulb is white light, and that's made up of all the colors of the spectrum, lots of different wavelengths. But imagine this is just a single wave.
That's probably too fast. Yeah. Probably wasting too much time just changing the speed, but yeah, it is a little slow.
Wavelength of light, and you can see the light is coming out in waves like ripples in a pond.
Right. So they're going to keep saying that's what's happening in the real world, that it's coming out in waves like ripples in a pond. So we know ripples in a pond are they're just a transmission of pressure between adjacent atoms. The atoms are just pushing each other and saying, spreading the push, one like a cascading dominoes. And light isn't necessarily doing any of that, and it's at a frequency in the sense that it doesn't come out of a light bulb like that either. It doesn't come out blah 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 blah, all the same frequency. The photons each have little rays of photons that shoot out, are all at different phases, so it's not even a consistent frequency, where like a radio wave would be, because we feed the frequency into the antenna. We say all the photons now, and we say off, and we say on, all the photons now, then off. So they're always in phase. But light doesn't come that way. All the little rays of light are not in phase. So this is another deception.
That's the nature of wave-like behavior. As the light hits the screen, it squeezes through the two slits, and each slit in turn on the other side becomes almost like a new source of light.
So it doesn't really squeeze through. It either goes through or it doesn't, but it doesn't really get squeezed in through the slits. But anyway.
And the light spreads out. It diffracts. And as the waves of light...
So again, he says diffract, and that could be understood to be that diffraction is like refraction inside of a medium, in the sense that it's really light hits electrons, and the electron moves a little bit, and then the light's readmitted in a new direction.
Overlap, they will interfere with each other. So where a crest hits a trough, they will cancel. Where a crest hits a crest, they will amplify, and so on.
Right, and another one of the defects in this theory is the pattern doesn't come out the way it's supposed to, which is a nice clean sine wave. The light isn't distributed that way. So it's distributed in basically very strong bars and very reminiscent of a bunch of images of the edge of the slit.
And so on the back screen, you end up with what's called an interference pattern, a series of light and dark fringes.
So again, the conclusion that anything that looks on-off is reminiscent of, or we should automatically think, is that interference. You know, there's no other logical explanation than to say that must be interference. When no, there are logical explanations. Don't require anything to interfere with itself or anything else. Again, the asteroids don't need to interfere with other asteroids to be deflected. Now, to be deflected in lines, yeah, they would need to interact with something else in the environment. Little moons around the Earth and Mars, let's say. And they hit the moons instead of going straight through. And the moon moves a little bit and the asteroid bounces off at a new angle. But you certainly don't have to, you know, extend too much imagination to understand there can be explanations that don't have anything to do with anything called interference. They just have to do with the fact that you're interacting with a system
where the waves have either cancelled out or worked together in phase. That's fine. That's not quantum mechanics. That's a property of light that goes back over 200 years.
Okay, that's not quantum mechanics, that's a property of light. So again, this argument that it's a property of light that goes back 200 years, well, you know, it goes back further than that actually, but it wasn't understood. Newton didn't have an explanation for it. Young didn't have an explanation for it, I mean a rational one. So it wasn't like there's some non-quantum mechanical explanation that pre-existed. So let's understand, it's another reason why they jumped to this stuff was because they hadn't really thought about it. They had to first, you first have to know there are electrons near the surface of objects. You first have to know a lot of stuff before you can draw conclusions about what's happening. You even have to have an understanding that matter isn't what it appears to be. You know, it appears smooth and straight and everything's, you know, like it's a real hard surface. But from the perspective of the tiny little photons, we already know that atoms are mostly empty space, so that this surface isn't anything like some sort of rigid surface that a photon just bounces off of the empty space. It just bounces off of the idea of the atom. No, the photon actually has to interact with the parts, the nuclear bits inside the atom. It can't just bounce off the atom. It has to bounce off something inside of the atom. And all of that logic hadn't been figured out yet.
That we've known about since the early 19th century. Imagine doing the same experiment again.
The early 19th century, he said. So again, it goes back to Young, but he doesn't go back to Newton. Newton is where it starts.
But doing it not with waves, but with particles. Do it with grains of sand. So this is the same experiment, but I've tipped it 90 degrees.
So this is, again, just perverting it to your purpose. So use examples that are not indicative, where he could have used the big world example, as I pointed out, of Mars and the Earth and an asteroid going between them, because then you won't get just a straight through. So, you know, yes, you can always find some mechanism to distort. Now, if he would have used water, single droplets of water, and dropped single little drops of water through those slits, he would have gotten a diffraction. He would have gotten a not straight path straight down, because water does get charged through its movement, and it will react to the charge on the surfaces. So I mean, it just depends on what experiments you do, whether or not you can point out the defects. And clearly they use experiments to say, see, this is what particles do. And of course they're just using experiments molded to point out that, see, there is no phenomenon, instead of any balance, and saying, no, there's plenty of particle experiments I could show you where I could take a styrofoam ball and throw it through a slit, you know, a big slit, and you'll see it move because it has static charge. So again, it's just their choice to use an experiment where the force is negated, essentially, because of the dimensions of what they're doing and how they're doing it. Like I said, they're dropping sand all at once. If they would have taken those grains of sand and dropped them singly, they might have gotten a pattern.
Rather than waves that are spread out that wash up against the two slits and squeeze through, here you've got individual particles of sand, and each particle will either go through one slit or the other. And so you see they will sort of drain through, and you get...
Yeah, well, that's another whole part of the canard of this. Obviously, this isn't even to scale either, because the two slits should be much closer to each other. But just this idea that there's some reason to believe that we're going to be able to defend some notion that the photons, you know, a kind of sand, goes through both slits at the same time. That, you know, that's the place they want to try to defend. When logically it doesn't make any sense if you understand that the single slit creates the same phenomenon, because then this isn't going to do any good. This idea of having two slits to create two waves isn't going to work when you have to include the single slit, takes a single grain of sand and somehow makes 2 grains of sand out of it without having the second slit. So again, there's no logical continuity to what they're doing. Alright, so we'll do some of this Hoflade video. He has the different experiments in here. He doesn't really go through them very deep, and he just trivializes explanations. So there's an explanation I've tried to make, and I'll re-illustrate another way. But I've talked about tipping point. You know, if you shoot bullets. So there's this argument that frequency became associated with energy. So they think that an ultraviolet photon, the bits inside the ultraviolet photon, are somehow more energetic. They've got more power innately. They have more momentum. If they converted it into an electron, it'd be an electron moving faster. And I would argue that no, they're all the same. Okay, infrared light, ultraviolet light, same exact pens. They're just closer together. They just come more rapidly. And that has a consequence in the sense that it can appear like that's more energy, but it's really not. It's just a circumstantial effect with electrons. So I've illustrated before by talking about tipping point. Okay, if you're shooting bullets and you want to knock something over, if you shoot the bullet slowly, then the thing will get hit with the bullet, move, and then it'll move back, and then the next bullet will hit, and it'll move over, and it'll move back, and the next bullet will hit and move over, and it'll move back. So you won't tip it, because you have to tip it. You have to hit it when it's halfway. You have to let it move. See, the bullet moves faster than the thing's going to move when it's tipping. So the bullet hits going very fast. This thing takes time to develop that speed, and so it tips, and then you need to hit again there, and then it'll tip over, because it won't be able to rock back. So that's a tipping point. Now another way of illustrating that is to say, let's say I have a trampoline surface. I don't know whether I'm in the frame here or not. Camera's a little bit buggy that way. Okay, so I have like a trampoline, a bendable surface, and it's a little gluey, and there's a tennis ball stuck on it. And so now I'm going to hit the tennis ball, and it's going to push the trampoline in, and then the trampoline will bounce back. So you can sort of understand it's the same effect. If I hit the tennis ball, it trampolines in and it bounces back, but it doesn't bounce back fast enough for the tennis ball to be released. Not enough pressure created. But if I hit the tennis ball rapidly enough, that is, the frequency is high enough of the impacts, then the compression will happen, and the second hit will happen, and that means it'll compress a little bit more. And then when it springs back, it's going to release both of those hits, and then the tennis ball will fly off the glue. Now that's the explanation you can have. That's just a purely mechanical explanation for the photoelectric effect, for what Einstein realized in terms of you need a certain amount of energy to release a loosely held electron. So we're talking about electrons on the surface of metal that are loosely held, and it takes a certain amount of energy, a certain amount of pressure to pop them loose. And the only way the pressure has to be, and the real trick is that the electrons have a tipping point. It's like a bunch of magnets stuck to each other. Okay, so I put a bunch of magnets all facing the same way, heads up, and they're repelling each other, and they're also being attracted by a center magnet that's positive. So they don't like each other, but they want to get to the center. So I have a tension set up in those magnets. You could understand that if I poke one of them, it'll jiggle and go back to its position. You've seen magnets do that, like they jiggle in midair when they're caught in tension. So it'll jiggle. But if I hit it twice, that is, I hit it once and I hit it again, you can sort of think about it and say, yes, I understand how that would pop the magnet loose. So there's a perfectly rational explanation, perfectly mechanical, sensible to how we have developed a physical understanding of how the big universe certainly works. You know, things crash into each other. There's no evidence of any magical forces anywhere. The forces seem kind of obvious, you know, conceding that you have some notion that gravity isn't, you know, magical. You know, that's probably being caused by a force of some kind. But exclusive to that, just saying that gravity is a property of these material bodies, everything else that happens is really simple. The force interacts with the force in terms of the material thing interacts with the material thing, and they're both carrying the force. So now force can interact with force, because my force will interact with your matter, the force you create will interact with my matter. So there's that conduit. So it's a perfectly rational explanation, and yet they chose this, you know, bizarrely weird wave notion. So again, where now they gave the idea of bullets weren't just bullets, and speed has advantages. So you can just relate it to bullets. You kind of understand that if I shoot 10 bullets in 10 seconds, or I shoot 10 bullets in 20 seconds, each individual bullet wasn't a stronger bullet. Each individual bullet wasn't a heavier bullet. It's all the same bullets. It's the same amount of energy I've released. I've just released it in a way that in certain circumstances it will be able to do more work. And that's it. It's just circumstantial. It has nothing more obvious work. It won't be any more real work. It'll just be more obvious to us because we think certain things happening indicates good, you know, more work than other things. The tennis ball flying off to us seems like more of an event than if I just kept knocking the tennis ball into the trampoline. Anyway. So yes, simple explanations. You don't need these convoluted ones. So, and Hofladay thinks that tipping argument is just something you're just, some wacky theory. It's just some wacky notion.
The frequency of the light should just keep going higher and higher and higher the hotter and hotter it gets.
So this was another thing, was the black body radiation issue, the ultraviolet catastrophe. Another circumstance where you just say we had no right to presume, okay, that it works this way, that somehow because it starts off that atoms are producing wavelengths of, first they produce radio waves as you heat them, and then the microwaves, and then gigahertzes, and then megahertzes, and then finally photons. And that because there was a scale of what atoms can produce in terms of frequencies, that we should assume atoms can produce mega high frequencies, that we can go as high as we want, doesn't matter, and they'll be able to produce these supersonic kind of frequencies out of the material in the atom. There was no reason to presume that, and you certainly don't need quantum mechanics to understand that no, there's this limit, and once you get past like ultraviolet, once you get close to ultraviolet light, what the sun produces even drops off. because there's no mechanisms inside the atom that can manifest that pressure naturally. You have to create a very unnatural condition inside the atom, because the pressure is really what creates a high frequency, is pushing electrons together, making them more fairly uncomfortable with each other, in a sense of forcing them together into tighter and tighter relationships. And then the little bits that are jumping between the electrons, which are the photons, have to jump between a narrower and narrower gap. And so because they're bouncing between a narrower and narrower gap, that's a higher frequency. But there's no natural state inside of atoms where electrons can be that close. So they don't naturally produce a bunch of ultraviolet light because it requires too much electron pressure to make. Simple explanation, no quantum mechanics required.
When in fact what is observed is the black body spectrum, where you get a maximum of one particular kind of light, but as the temperature goes up you get more and more ultraviolet, but it wanes off.
I think actually the chart goes the other way around, but regardless, it doesn't really wane off, it drops right off the cliff. There's very little X-rays produced, very little very little gamma rays. I mean, it's very, very little.
Yeah. So the thing is that the current predictions predicted an ultraviolet catastrophe, i.e., you can.
The catastrophe would be that yes, you'd have all this heat would create a ton of ultraviolet light. Ultraviolet light is destructive to atoms, therefore we're afraid of it. But that's all it is. It's just that ultraviolet light, obviously the system is sensitive to certain vibrations. It's like just that you can shake something a little bit and it's okay, and if you shake it too hard though, you smash it all to pieces. It's like an egg. Even you can move an egg back in in shell and it'll be okay, but you can actually scramble an egg inside the shell by shaking it fast enough. So clearly ultraviolet light is fast bullets. It breaks all the tipping points, so it knocks everything over. So it's just more destructive circumstantially, not fundamentally. It doesn't fundamentally have more power or more energy. It just circumstantially can create more damage to structure.
The thing should glow ever brighter in the ultraviolet. Max Planck, just by genius and trying something radical, found that if he quantized the notion of light, he could make the correct prediction.
Well, again, he could make the correct prediction. Well, anyway, this became Planck's constant. So now energy, it's written in Hoffade's video there, you can see HF. So it's Planck's constant, a very small number, 0.6 whatever, times 10 to the minus 16 or something. Very small, Planck's constant, times the frequency equals the energy in some sort of joules, I'd imagine. And again, the frequency really isn't the energy. That's just a timed equation, and that's what Planck's constant is probably just alluding to, is the smallest amount of distance traveled. But ultraviolet light only has more energy in the sense that obviously in the same amount of time, close things together will have more little bits and further things further apart. So that's just logic. But it doesn't fundamentally have any more energy in the sense that the bullets are not better bullets. They're not more capable. Gotta let the cat out. Come on, get out of the way. Meow, meow, meow. I'll be back. Probably. Yeah, so we'll play a little more of this.
Albert Einstein in was it 1905? This was like 1900 or 1898 or something. That Planck did that. Albert Einstein
Way too slow.
took that notion of quantizing light serious to say light is a particle, and this explains the photoelectric effect, wherein
Yeah, but still, you've already broken the particle thing by assuming the wave function is somehow meaningful. So the fact that Planck made the frequency the power when the frequency doesn't give the photons more power. So there's no continuity between these arguments. So clearly, yes, Einstein tended towards a particle understanding of light, but it was still particles in some sort of idea of electromagnetic waves that Maxwell had already perverted light into. Because Maxwell, the EMF, the electromotive force, the forces exchanged between magnets and conductors, and in Maxwell's equations, because that force was found to move the speed of light, he converted light into something electromechanical, electromagnetic, when there was no indication that it had any properties of magnetism or electricity. And that fundamentally broke this idea. If you're going to call it a particle, you can't force it to be some force at the same time. So, unless you're very clear about the fact that there must be particles involved in electromagnetism, and they weren't willing to go there. So, I mean, you can't say that Einstein was being classical, because it clearly wasn't a classical understanding as particles coming at a frequency. It was still thought of as corpuscles of electromagnetic force, which is a long way from a particle theory, in my opinion. Very long way. Alright, back to some more of this.
But both. Then I told you, you may expect that, but what you get instead, let's see, I got to pick my graph properly, is something that looks like this.
So you get exactly that same, something that looks like this, with one slit. So again, it's just a complete misrepresentation of the historical and factual record for the purpose of defending quantum mechanics as a perspective. If they told the story accurately, then the story's not going to be as easy to tell. It's going to seem even crazier if you tell the whole truth.
Now that is the phenomenon of interference which we studied last time. So what's the part that's funny? What's the part that makes you wonder? Is if you go to some location like this, go to a location like this. This used to be a bright location when one slit was open. It's also a bright location, reasonably bright when the other slit was open. But when both are open...
Right, so clearly there's it seems strange, okay, that you have two slits, and that there was some practical way that you could just block one of them, that you wouldn't change anything. But the fact is the other single slit is creating a pattern. So the idea that this was bright, not necessarily. It could have been dark with one slit open. They haven't done this experiment as a fact, where you have two slits and you block one, and then the light pattern, you can demonstrate that places that were completely dark are now completely light. But even if that were true, the idea is that you have two slits, and they're material things, and the matter itself has a balance of pressure, and that those having two openings in the material, those two slits will adjust to each other, so to speak. They will know of each other's existence in the sense that the forces that are reacting inside the matter will be aware of the fact that there's a hole in the matter. Okay, and that there's going to be a change in the subtle changes in the electrical charges inside the matter because of those holes. The matter will line up in a certain way, the atoms of the matter, because of those holes, those deficits in the lattice of the material. And so you would expect the pattern would change as you open and close more slits. But what's considered an opening and or closing is the tricky part here. Just putting a shield, having a slit here and then putting a shield here isn't going to change the balance. But again, these experiments haven't been done to prove or disprove these statements that are made.
When it becomes dark. You can ask, how can it be that I open 2 windows, the room gets darker? Why doesn't it happen there and why does it happen here? The answer is that you're sending light of definite wavelength.
So again, they haven't actually done the experiments. So you can't really tell whether that actually happens. That a place that it was completely dark, completely light, and I open a second slit and it goes completely dark. There's no hard evidence that that happens, because they denied the fact of what the single slit does, which is also create a pattern.
And the wave function psi, whatever measures the oscillation, maybe electric field, magnetic field, obeys the superposition principle. And when 2 slits are open, what you're supposed to add is the electric field, not the intensity. The intensity is proportional to the square of the electric field. You don't add.
So again, let's understand that the electric field means is that there is no particle theory here at all, because you can't. There's no electric field for a particle. There's no magnetic field for a particle. There's no stuff, flying out of it perpendicularly or up and down, or it's not doing any of this waving stuff. It's just coming at a frequency. So there's no field to affect. Whatever it produces, it has to produce as it is. Now I would argue that electrons can produce photons, gravitons, magnetons. They produce energy, but photons don't. Photons don't wreak any field energy. They don't make any magnetism, and they don't make any electricity in another direction. So they don't have any of this stuff. So there's no property they can. It's not part of the properties. Only matter has those properties. Matter can excrete photons. Photons can't excrete photons.
E squared, you add E. E is what obeys the wave equation. E1 is a solution, E2 is a solution, E1 plus E2 is a solution. No one tells you that if you add the 2 sources, I1 plus I2 is going to be the final answer. The correct answer is to find E1 plus E2, and then square that. But when you do E1 plus E2, since E1 and E2 are not necessarily positive definite, when you add them, sometimes they can add in the same sense, sometimes they can add with opposite signs, and sometimes in between, so you get this pattern. We're not surprised.
Yeah, well again, there is no adding photons or subtracting photons, so a photon either goes or it doesn't go there, but 2 photons don't destructively interfere because of some field that they're creating and that was their identity. So what all that happens is photons that would go to one spot go to some other spot because they interact with something that causes them to go to that spot. It's not because they decided to go to that spot, because they interacted with some invisible field.
And I told you many times why we don't see it when we open big windows. First of all, when you open a window, the slit size are all many million times bigger than the wavelength of light.
Right, but if you opened windows, if you thought of it again as an experiment where you had 2 planets and you created just 2 places where the asteroids could go through, or guns that only shot them from certain locations, you could certainly understand, alright, that those trajectories would have implications in terms of how close they are to Mars versus how close they are to Earth, and how much they're going to get deflected by how close they go to the planet. So there wouldn't be any mystery of the effect. But again, you can create experiments of different scales that will make it illustratable. And again, I could use styrofoam balls going through to windows, and the styrofoam balls will be deflected. They will be affected by the charge of the frame of the window, and they will scatter in interesting arrangements and patterns. Matt wants to come in. Ugh. You're supposed to stay in your chair too. You're not supposed to be drifting all over the fucking place, asshole. I'm getting sick of that. No. 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 Christ, it's just gonna be a pain in the ass today. No. No. Something like that anyway. It's deaf, like it's, makes sense to say no to a deaf cat. But I have no other weapon.
Destructive interference. So, we have these alternating tracks of wavy and flat water. Any type of wave should make an interference pattern like this. For example, water waves and sound waves, but also...
Yeah, well, it gets a little tricky, right? Any waves, because, you know, in some things, waves are vibrations, and you could never build slits inside of like a piece of steel or something. But regardless, so it's just let's force photons to be waves, merely because they're at a frequency, and it's just you can disturb a system. The electrons are essentially a medium in the sense that they're tied in tension. They're tied to the surfaces by attention, by attraction to protons and repulsion by other electrons. So they're in tension, like magnets. They're in tension in arrangements. So in a sense, they're a medium that can transfer pressure. So you can understand that something that has nothing to do with waving can poke that, like my finger, it's not a wave. I can poke that system, and the electrons will move that pressure through all the electrons. They'll all vibrate and transfer that. So my finger wasn't a wave. So again, to say a photon's a wave because it can affect a system that is a medium, that is in tension, and then travel through the medium and come out the other end, and the medium changed the direction of the photon, and then now they're saying, well, that's a wave, the photon's a wave. But no, it just traveled through a medium that can pass pressure.
So, light waves. This double-slit interference of light was first observed by Thomas Young back in 1801.
Right, so, but let's not mention that it was discovered by Newton in 1650.
A source of light passing through two very thin slits produces bands of light and dark stripes, alternating regions of constructive and destructive interference on a screen.
At least he's showing the right pattern in the sense that it has the extra bulges, you know, the extra on-off, so it's two interference patterns superimposed on each other, the two slit. And, you know, but of course he won't cite the fact that the single slit does most of that. You know, without the little ripple-y stuff at the ends, it does the middle part of that just fine.
That light is a wave in the electromagnetic field, thanks to the work of James Clerk Maxwell a century later.
Right, so Maxwell just messed the whole game up in the sense that, as I'll argue, I mean, his equations are fine, recognizing how magnetism is a perpendicular force of accelerating electrons and all that kind of stuff. That's all good work. But, you know, the forcing photons to now become electromagnetic because they notice they have the same speed as these little virtual force bits that were exchanged between a magnet and a conductor because they found that that speed of that transmission was the same as the speed of light, then they made light into electromagnetic force instead of the other way around. They could have just as easily, just like Benjamin Franklin could have said minus and plus and got it right instead of getting it wrong, Maxwell could have come to the conclusion that no, maybe electromagnetic force is like photons. Maybe it's just photons that are transmitting between, invisible photons, between a magnet and a conductor. Those were the two choices. I'd say clearly wrong choice.
So it makes perfect sense that it should produce an interference pattern, right? But wait, we also know that light comes in indivisible little bundles of electromagnetic energy called photons. Einstein demonstrated this through the
little bundles of electromagnetic energy. So again, it's hardly a particle description. It's hardly any kind of description at all. It doesn't say much. Little bundles of wavy stuff. No. They're little bundles coming at a frequency.
photoelectric effect, but his clue came from the quantized energy levels of Max Planck's blackbody radiation law. Check out our episode on this for the details. Okay, so each photon is a little bundle of waves of electromagnetic field, and each bundle can't be broken into smaller parts. That means that each photon should have to decide whether it's going to go through one slit or the other. It can't split in half and then recombine on the other side. That shouldn't be a problem, as long as you have at least two photons. One photon passes through each slit, and then the two photons interact with each other on the other side and produce our interference.
Right, so we already know, though, that photons don't interact with each other. We can't bang them into each other. We can't make them interfere in any way. We can shoot light at light all day long, and the two beams of light will not bounce off of each other. They won't destructively interfere. They won't constructively interfere. So, like again, this is just more fake argument that somehow we could possibly reason that individual photons would interfere with other photons, that one photon from one beam of light would interfere with another photon from another beam of light. We knew for hundreds of years that ain't going to happen. So this is more just kind of a fake setup.
Pattern. But here, we get to one of the craziest experimental results in all of physics. The interference pattern is seen even if you fire those photons one at a time. Well, let me back up a bit. The first photon is detected as having arrived at
there's no real reason to back up, but yeah, so this is the idea that so here you find out that, hey, wait a minute, when you do this experiment with just single photons, you still get this interference pattern, which means that each individual photon has somehow is obeying this probability equation. And again, but no argument that why don't we just blame the matter? The material thing is the variable in this experiment. They just pretend that material thing doesn't exist, that it creates no phenomenon, that it doesn't do anything, and that the photon is doing everything. So here you have the complex screen, the screen made of billions and trillions of atoms that have surface electrons. That complex system is completely ignored as a cause of any event, and instead we're going to find all the causes inside the little tiny photon, which we historically know is incredibly difficult to fiddle with. I mean, it's it's like a force. It doesn't interact with forces. It does one thing. It goes the speed of light in a direction. That's what we see it do all over the place. And yet, what did they do? Instead of blaming the matter for causing the effect, they blamed the little tiny thing, the tiniest thing we know of in the universe. They blamed it. Again, you have a choice, 50-50. What do you blame for the phenomenon? The slit material, that's highly complex matter, or the little photon that you know to be incredibly simple matter? Getting that answer wrong just seems really, really dumb.
very particular location on the screen. The second, third, and fourth photons also. They deliver their energy at a single spot, and so they appear to be acting like particles of well-determined position. But check it out. If you keep firing those single photons, you start to see our interference pattern emerge once again.
And again, all you need to create that pattern is some rule that if a photon hits an electron between those two slits, the electron moves, changes direction 3 degrees, and readmits the photon. And the 3 degrees would just change based on the frequency of the light. So if the light goes to a higher frequency, you just change it to 2.5 degrees. And if it goes to a longer frequency, you change it to 5 degrees. But anyway, so every electron just moves a standard 3 degrees if it's hit by, say, 400 nanometer light. And just by that logic, you can create this pattern. And there would be more stuff in the middle and less stuff on the outside, and it would create light and dark, light and dark. A simple explanation. You don't need any religion here to explain it as a phenomenon.
By the way, Veritasium actually conducts this experiment in his excellent series on the double-slit experiment.
Yes, I did play that video and comment on it. I can't remember. There's a couple of flaws in his experiment also. But anyway, won't do that now.
Really worth a look.
But I mean, yeah, you look at the pattern that he's showing from even Veritasium's video, and there's no smooth gradation. There's no sine wave distribution, and that's how it should be. There should be very bright in the middle, and then it gets less and less bright to a very dark line, and then gradually light, and then gradually dark, and then gradually light. It's not there.
In his excellent series on the double-slit experiment. Really worth a look. This is so bizarre. This pattern has nothing to do with how each photon's energy gets spread out, as was the case with the water wave. Each photon dumps all of its energy at a single point. No, the pattern emerges in the distribution of final positions of many completely unrelated photons. How can that be? Each photon has no idea where
each photon landed in a position. See, they've already bought into this idea that the photon doesn't know where it's going, that each place it goes, it doesn't matter. But no, each photon actually went a specific location. It went close to a surface, far from a surface, right through the middle of the surface, and each one of those has different probabilities of your outcome. And they just totally ignored that also. Totally ignored.
Previous photons landed, or where future photons will land. Yet each photon reaches the screen knowing which regions are the most likely landing spots and which are the least likely. It knows the
It knows. So again, the photon knows something. No, the photon was deflected, just like an asteroid flying between the Earth and Mars will be deflected by the gravity, and the slower you move the asteroid, the more it's deflected. The faster you move it, the less it's deflected. And yes, you'll get a pattern, and yes, it won't have the dark bands, but the dark bands can be created just by creating a few little moons in between the Earth and the Mars, and allowing the asteroids to hit the moons first.
Interference pattern of a pure wave that passed through both slits equally, and it chooses its landing point based on that. It turns out that the photon isn't the only thing that does this. Shoot a single electron through a pair of slits, and it'll also appear to land at a single spot on the screen.
So let's understand, electrons hitting electrons, essentially. So same experiment in the sense that, okay, now you're throwing something into this atmosphere, and the atmosphere still has the electrons in it. So some of the electrons are hitting other electrons. Some of the electrons are likely getting deflected by the forces that are holding the electrons, so the proton forces are bending them. And that's why the pattern's a lot smoother and a little blurrier, a little less intense. And then you do it with atoms and it gets even less intense, more noise. And if their theory is correct, you're supposed to believe that, say, 60 carbon atoms thrown at this two-slit experiment, somehow the 60 carbon atoms dematerialized, turned into two wave things. The wave things went through both slits. The wave things interacted with each other and then it turned back into 60 atoms again to hit the target. And you're supposed to believe that's reality. And I say that's a three bears story. That is preposterously silly.
But fire many electrons and they slowly build up the same sort of interference pattern. This crazy effect has even been observed with whole atoms, even whole molecules. Buckminster fullerene. Buckyballs are gigantic spherical molecules of 60 carbon atoms and have been observed to produce double-slit interference under special conditions. We have to conclude...
So again, under special conditions, and he certainly didn't show the results, which are quite feeble, to say the least. So again, just more implication, like, no, it fits. Don't worry, you don't need the details. But yes, atoms do exactly the same thing. They dematerialize. They don't have a position. You can't shoot one at a location and have any chance of it getting there reliably because it might go to Pluto. I mean, it's just a complete denial of that the evidence isn't strong enough for these conclusions. Not even close to it. Anyway. Alright, so what's this one? We'll do this one some more.
Two bumps underneath each of the slits. So the two peaks is reminiscent of particle-like behavior, whereas the multiple pattern of interference is wave-like behavior. What if we do the same experiment with atoms? Well,
so clearly he just said particle behavior is you can't scatter particles. Particles won't diverge. Whereas I just pointed out, certainly you know electrons will if I put them through charged plates. We know that asteroids will if I put them in between two gravitational bodies. Clearly it just depends on the force environment. You have to have an environment where the force can be exercised, and then you'll have the effect. Photons can't be bent by any force. So photons can only be bent by interacting with moons, so to speak. They have to interact with a catalyst material to be able to be deflected. That's the only rule. That's not an outrageous, bizarre theory. Yes, photons hit things. When they hit things, they put their momentum into it for a moment of time, and then when they leave, they'll leave at a different position. They'll have a different vector when they leave.
Imagine we have an atom gun, something can fire atoms, a stream of atoms. You can't see them because they're very small. Let's block off one of the two slits. So these two slits are the dimensions and separation of the slits is chosen appropriately to show us how atoms do things. And so far so good, nothing strange here. You'll see a lot of atoms.
So again, the same argument as if there you will see, and no, that's not true either. If the buckyballs are moved by the two slit experiment, they're going to be moved by the single slit one too. But, just more deception. Cold, hard dishonesty. The single slit is a real phenomenon, and it's just being overtly denied in this example. It's like pretending it doesn't even exist, that Newton didn't discover it. He did. 300 fucking years ago.
Hitting the back screen. So this will now have to be some sort of photosensitive screen whereby when an atom hits it, it'll give off a little flash of light to say the atom has arrived here. So the atoms are arriving as these little pinpricks of light that we see. Of course, a lot of the atoms will be blocked by the first screen. They won't go through that slit. But those that do get through to the other side, you can see there's a bit of spreading of the atoms. But if we didn't know anything about atoms, we'd say, well, that's fine, we can understand that.
So again, just called a bit of a spreading. So he's using the atom example as if it's a metaphor for the photons. So first he's analogizing the atom one as if this is the same as the photons and the electrons, when each experiment is different and the results are very different in terms of the quality of the pattern produced. So, this is all just such rubbish. And clearly we know that with photons and small apertures, the pattern is rich and strong. And it's just wrong to imply that it's not there. It's there, and it's real, and it's substantial, and this nonsense doesn't account for it.
Atoms are going clean through the slit. Some are sort of maybe bouncing off the edge of the slit, and so they're sort of being deflected a bit, which is why you get a bit of a spread. The first mystery of quantum mechanics comes when we open the second slit. Because now we see something that's very much like the interference pattern we got with light. Rather than have
So again, this isn't a real example. This is a complete exaggeration. The pattern produced by buckyballs is nothing like that. Not strong at all. Couple of bars, really fuzzy, not even close. And again, and this requires the denial of the pretense that they did it with a single slit and they couldn't make any of the buckyballs move with a single slit. And that's a lie. It's just a misrepresentation of the truth. First, if you don't have the evidence, if you don't even know of the evidence, you can't claim the evidence exists on your side. So I'd even argue this guy has no personal knowledge of any of this crap. He's just spouting a routine story, a routine narrative. He's just telling the same story he was told. And it's not based on anything factual. It's not based on any real experiment that was ever conducted.
having two bands of spots where the atoms have gone through the two slits, it's as though the atoms have gone through the slits behaving like waves. And you get...
It's as if, though, yes, if that's your interpretation. And I would argue that you have choices in terms of how you interpret. And you're choosing badly. Plainly. So back to Yale, where he chooses badly also.
Light is not just one color, and so on. So you don't pick up these oscillations. These oscillations are very fine. I draw them this way so you can see them. In a real life thing, if this were really windows and this was the back wall of your house, the oscillations would be so tightly spaced, I'll just draw some of them, that the human eye cannot detect.
Yeah, well, it's really not the human eye detecting them is the problem. The point is a big window, tiny photon. Obviously, there's the percentage, you can imagine the percentage of photons that travel next to the frame of the window would be minute compared to the ones going through the middle where they're not going to be affected by any static charges or electron charges. So clearly that's the proportional difference, is you've made the opening so big that there can't possibly be any influence for most of the photons. Most of the photons go through completely unaware of the existence of the window.
These oscillations will only pick up the average value. The average value will in fact look like I1 plus I2.
Says him.
So this is all very nice. This is how Young discovered that light is a wave by doing the interference. I told you.
He didn't discover it on purpose in the first place. He didn't discover anything. Newton discovered it, if you're going to say it's a discovery. If you're going to say interference, light interference means light is a wave, then you have to give Newton the credit and say he discovered it, because Newton is the one who did the frickin' experiment first. He's the one who figured out that apertures create interference patterns. So again, they're just denying that. Newton didn't, it wasn't Newton's blob. Newton's not famous for discovering Newton's blob. You know, light diverges when it goes through a small aperture. It just diverges into a blob. He's not famous for Newton's blob. He's famous for Newton's rings. The rings are the pattern of interference. So again, this is such a misrepresentation of the truth. The Young experiment is completely uninteresting when you already know about Newton's rings. The single aperture creating the frickin' pattern is a far more difficult thing to explain than the double slit. The single slit's a lot harder to explain.
You can find the wavelength because it's a simple matter of
Well,
geometry
especially quantum mechanically.
to see where you got to go for two guys to cancel. Then once you know that angle, you know where on the screen you will get a minimum or a maximum.
So again, the
wavelength, you don't
angle
know what.
that's theta in the mathematics, the angle created, is exactly the angle I was talking about, but with the electron. You can make it an arbitrary value in the sense that you can just establish that there's a fixed angle for every frequency of light. So it's like you can do that before you even do the experiment. You could already establish that, 400 nanohertz lights are going to create a certain theta. And it doesn't matter how far away the target is. It doesn't matter. All the other stuff doesn't matter. That's going to be established. A certain theta is going to be created by a certain frequency of light. Now, the width of the slits in the single slit makes a difference. So as you make the slit width, as you bring the two slits closer to each other, you change the amount of electrons, and that'll change the angle that they leave at. So the theta is going to be dependent on two factors: the frequency of the light and the width of the slit. So you know that going in.
Was doing it, he didn't know it was electromagnetic, but you can get the wavelength. So Interference is the hallmark of waves. Any wave will do interference. Water will do the same thing. For example, this is your beach house. You got some oceanfront property. This is a little lagoon, and you have.
I don't know if we want to do this again. I've played this in the past already. This is just the boat example that the boat's rocking, so you make a second hole in your wave break, and then your boat will stop rocking. Well, again, they haven't done that experiment with light, so it might be interesting to see if that actually turns out to be true. Because how you make a new slit or how you cover a slit is important to this phenomenon. And I'd say there's no experiments that can really deal with that, because mechanically any shield you put into the experiment is going to change the experiment. It's hard to put new matter into the experiment without that new matter changing the very charge field I'm talking about. The pressure of the electrons is going to be changed when you introduce another piece of matter into the experiment.
That each individual photon, electron or buckyball travels through both slits as some sort of wave. That wave then interacts with itself to produce an interference pattern.
So he says the sentence before that was, we have no choice but to conclude that it has to go through both slits, and it has to do this, and it has to do this, and it has to do that. And no, none of that has to be the truth. It doesn't have to be your truth. It doesn't have to be physics's answer. They've chosen that answer. And just like Benjamin Franklin got it wrong, they've got it wrong.
Except that here the peaks of that pattern are regions where there's more chance that the particle will find itself. It looks like a wave of possible undefined positions that at some point...
Well, let's understand that the wave of probability is that there's a high probability it goes to the center, 80%, and then there's a 10% chance it goes here, and then there's a 4% chance it goes here, and a 2% chance it goes here. So, I mean, the chances aren't all that wacky here in terms of an explanation that, yes, there seems to be a quite logical... There's lots of empty space in the middle, and the closer you get to the surface, one side, yes, less photons go right near the edge, less photons get deflected a lot. I mean, those correlations exist. So this isn't beyond any kind of rational deduction. It's not like the pattern's so wacky it's not explainable. It certainly is by simpler mechanics than the assumption that photons break in two and go through both slits.
For some reason, resolves itself into a single certain position. We also saw this waviness in position when we talked about quantum tunneling. In fact, several quantum properties like momentum, energy, and spin all display similar waviness in different situations.
Let's understand that they already turn momentum into a wave function. They've already turned it into a frequency. So de Broglie's bullshit already does that. So the buckyballs, they do the same thing. They shoot them at a certain speed, and they say their speed is now a frequency, when it's not.
We call the mathematical description of this wave-like distribution of properties a wave function. Describing the behavior of the wave function is the heart of quantum mechanics. But what does the wave function represent? What are these waves of, or waves in? Let's start with what we do know about the double slit results.
Yes, well, they don't have no clue is the truth there, so that's why I didn't answer the question, is because, yes, they don't have an answer of what these are waves in. A phony field that creates magical sources of moving energy. It can move stuff with the magic energy.
We know where the particle is at both ends. It starts its journey wherever we put the laser, or electron gun, or buckyball trebuchet, and it releases its energy at a well-defined spot on the screen. So the particle seems to be more particle-like at either end, but wave-like in between.
Right, so no need for that. The particle-like part at the beginning and the particle-like part at the end are the truth, and the fact is it was a particle all the way through this thing, and the only thing you need to do is recognize that matter is complex, And that matter is what the photons are interacting with. That's the thing in between the photon and the target. Between the gun and the target is a piece of matter, and you can actually blame it for things. And if you do that, you can answer your own questions.
That wave holds the information about all the possible final positions of the particle, but also about its possible positions at every stage in the journey. In fact, the wave must map out all possible paths that the particle could take. We have this family of could be.
Right, so the whole pinball machine is created by so I warp the board that makes the pinball machine. I create a blob in it that doesn't spread. It's just a blob of perturbation, a lump. And the lump imagines the pinball machine forming and the bumpers and everything else. It creates their locations and imagines them in all different kinds of locations, and then averages all of its imagined circumstances. It averages all the imagined bumpers that could possibly be in the universe, and then it establishes where the averages are, and then it interacts with the averages. That's their explanation of a pinball machine.
Trajectories from start to finish. And for some reason, when the wave reaches the screen, it chooses a final location. And that implies choosing from these possible paths. So what caused this transition between a wave of many possibilities?
A wave of many possibilities. See, it's just a religion. It's just a religion. It's not physics. Alright. Do a little more of this and get out of town.
Interference of the waves if you get these bands. If we know nothing about atoms or quantum mechanics, you could try and rationalize it and say, well, maybe atoms behave in a very strange way, and only a certain number of them are allowed to all sit together. And so, me and my gang, we're all going to go on this slit. No, sorry, no room for you. You go to the next slit above. And by the way, there's this rule that no one can go in between the two bands. But if you...
So they just keep making up all kinds of preposterous stuff like there's no reasonable explanation. So they just compare their irrational explanation to some more irrational explanations. Say, look how rational our explanation is, because look, it's a lot better than that. Well, there's a bunch of leprechauns, and they call UFOs from another dimensional galaxy, and the UFOs come here and shoot the photons with ray guns that bend them. Yeah, okay, that one's wackier than our theory. Not much wackier, but yeah, that's wackier. But it doesn't compare it to some kind of rational explanation that, yes, the matter's complex. The matter has a whole bunch of, every proton, electron, every atom is all tied in tension. And when you have an opening, a surface, surfaces are very tricky for matter, and surfaces have to form and settle. And that those surfaces are places where there can be a lot of electron activity. Wow, what a bizarre leprechaun theory that is.
You naughty atoms do, so there's a bit of a scatter. We don't. There could be some forces between atoms that make them coordinate their actions in a way to give this pattern. That's not mysterious. That's just, we just don't know how atoms do things. But we can be...
Yes, exactly. Atoms are under pressure, and they're all tied to each other through that pressure. One can't do something silly without all the other ones knowing he did it. There's no, one atom farts, everybody else smells it.
And we can force the issue. What if we were to not send the atoms all through at once, but send them through one at a time? Leave enough of a gap for the atom to get through to hit the screen. Of course, as I say, some atoms will hit the first screen and not get through, but those that get through will hit the back screen. So let's...
Right, so he understands that there's a difference between hitting the matter and missing the matter, so he gets that. But he doesn't get that there's a difference between going close to a surface and going right through the middle of the surfaces. He doesn't understand that.
Run the experiment again slowly, and gradually you'll see, as the atoms go through, they'll look like they're just randomly arriving on the other side. You keep sending atoms through one at a time, and gradually that same pattern appears. So
when they say the same pattern too, that's always kind of tricky, because these patterns aren't exactly the same. And as I pointed out with the interferometer, the pattern's quite different in terms of the distribution of those lights and darks. And they're not in the same probabilistic, they don't have the same probabilistic curve as an interference, a traditional interference pattern. And those should be little warnings that go off and they say, wait a minute, maybe it's not interference if it doesn't have that pattern. It's not interference in this case either, but you know, I'm just saying.
Each atom by itself is somehow contributing its small part to the overall wave-like behavior that we see in the interference pattern. How does it do it? How does, we know the atom's a tiny localized particle, we can't see it, it's too small to even see under a microscope, we're firing it at the screen with the two slits, some moment later you see a flash of light on the back screen. It's arrived in a localized point, it's not spread itself out. You don't get like a...
Yes, exactly. It's nothing like a wave. Nothing gets spread, nothing spreads like waves, so the word wave doesn't really mean anything anymore because they've taken something that's a movement through a pressure that moves in all directions through a matrix of atoms or a matrix of things tied in tension and broken the whole concept of what waves are. By saying you can have some sort of localized laser wave or something.
Wash off with sort of a faint light across the whole screen. So a little point, the atom is localized, arrived in a certain location, and yet it somehow seems to have been aware of there being two slits, not one, because it's given rise.
So these conclusions. He's in a black suit with a white shirt and a bow tie, talking. Somehow the photon knows. That's reasonable. That's how a physicist should talk. Somehow the photon knows. The photon has a very good friend called Leprechaun, and he has a friend called Pixie, and fairy dust.
To this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both? Well, we can try and be even cleverer. What if we were to spy on the atom and see where it goes? We can gently just observe which slit it goes through. So you put a detector just above the upper slit that will flash.
This experiment hasn't been done. So again, he's saying they did it with atoms. They didn't do it with atoms. I can't find it. So again, that would be an experiment worth doing, because atoms you can detect. The buckyballs you could actually detect which slit they went through without interfering very much with them, because you could bounce light off of them and you're only going to hurt them a little tiny bit. So you could definitely detect what slit they went through. They didn't do this experiment. I haven't seen any citation to this experiment ever being done.
Will beep whenever it sees an atom go through that top slit. Sure enough, you find...
So again, this is a story. They just used to telling this story. So they used to tell this about photons, that you put a detector on and you detect which slit it went through, or electrons, and you detect which slit it went through, and then you turn off the detector. And these are experiments that were never done. They just cite them as if they're real experiments, and they were never done. Because you can't do it as a practical matter. We don't have the technology to make a detector fine enough to be able to detect what happens at one slit without affecting what happens in both slits.
The atoms through, one at a time. 50%.
You can sort of just understand that if this phenomenon is very delicate, you put a machine that's going to be absorbing or creating or measuring electrons, it's going to have all kinds of noises built into it. It's going to be creating its own magnetic fields and all kinds of things. We can't do it. It's not physically possible.
Of the time, the detector will beep. The other 50% of the time it doesn't, the assumption being that the atom has gone through the lower slit. But of course I've been cheeky here, I haven't shown you the results of the experiment. That's what you get.
So that's horseshit. I'm just saying, I'll say that's horseshit, because there's no citation to this experiment. The buckyball experiment doesn't even have good enough results to be able to almost tell the difference between that result and the real results. And I've seen nothing where they actually attempted detection. So this is just made up. This is just part of their three bears story, and they need to they do the three pigs first so the three bears doesn't sound as wacky, but it's just complete nonsense. This didn't happen.
50% of the time, it beeps, and you see a spot arrive adjacent to the upper slit. The other half of the time, it doesn't beep, but you see a spot arrive at the lower slit. So, yeah, it's...
So, and again, you see a spot arrive at the lower slit, and you're saying, well, what, so he broke Newton's rings too? So Newton's rings doesn't even work anymore? A single slit doesn't create diffraction in a pattern anymore? That's the implications of this, right? I mean, if they just go straight, then you've gone all the way back to Newton and undone Newton's rings as a phenomenon. You've fixed the small aperture diffraction problem. So if you can actually make light go straight, you know, and not diffract anymore and not interfere with a small aperture, well, then you can fix microscopes and we can make them actually work better. Because optical microscopes can't work because of that diffraction. So if you can get rid of diffraction by merely putting the detector on the microscope and detecting the beams as they go through, you know, or trying to detect. So if trying to detect means you've straightened the light, then you can fix microscopes, and now we can have regular optical microscopes they'll be able to see much smaller things because we won't have this diffraction problem. I mean, see, this can't make sense. This can't be the truth because it doesn't fit with the other things that are rock solid evidence of. There's no fixing diffraction. You can't fix it. If there was a fix, we would have already fixed it. We'd have much better microscopes. We wouldn't need electron microscopes. We wouldn't need to coat things with a layer of silver or gold to be able to see them.
Picks out the atoms that have gone through the upper slit and not the ones that have gone through. So each atom does go through one slit or the other. But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms, surely now.
So we can do this sneakiness and we can do these, and so he's just talking as if this is real science and that they have really picked at this and done all these careful examinations and charted everything carefully, and none of that took place. 8,000 thumbs up, 320 thumbs down. I mean, you know, everybody just buys this fake story. This complete fantasy is now real physics. And you people are insulting me. So you're hurling all these insults at me, and you don't see that this maybe is worthy of an insult? That you don't dress up in this formal suit like you're going to talk formal science, and then you talk absolute horseshit that never took place? That you have no evidence for whatsoever? Zero?
You know, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Make them think that you're still detecting them. So, yeah, okay, we're going to run the experiment. Atoms, okay, get ready, one at a time. We're going to be checking on you. All right, so run the experiment again. Now, if you can explain this using...
Yes, and so if you can explain this as anything in the real world, no, it's not a real world. This never happened. This is just a complete bullshit, horseshit, fucking fairy tale. And it's sold as real science. This is why people believe this crap, is they think this is a real experiment. They think this really happens. And it doesn't. This whole thing is propaganda. Preposterous exaggeration. That's what propaganda is, not telling the truth. Propaganda is distorting the truth for a purpose. And this is distorting the truth for a purpose.
Common sense and logic. Do let me know, because there's a Nobel Prize for you.
Right, so I should get a Nobel Prize for merely saying, obviously you don't give a shit about the truth, that you just butchered the historical record to pieces and created a whole narrative that never took place. And I should get a Nobel Prize for that? No, I should get a Nobel Prize because I'm not stupid enough to fall for this wacky, extraordinary explanation when there's a simple, ordinary explanation that solves all of these questions, that answers all of these questions. Simple, logical, tipping point kind of arguments, not complicated, no magic needed. You know, again, they did this with like Easter Island, and it kind of affects the whole idea of how the pyramids were made. But they found that they could move those big, giant rocks, right? It was a big, huge mystery. How'd they move the rocks? And they figured out all they do is tie a few ropes to them, right? And they just rock them. And they can just rock them in a forward direction. No problem. couple of hours, they could move it, hundreds of yards. No problem. I mean, there can be simple answers. No UFOs required. And it just seems like physics, just every time it has a chance to reach for a UFO bullshit story, that's where it goes. It just doesn't like a boring physics. It has to have all this crap in it. So let's do a little more health today and we'll be done.
Only light of certain types turns out to be the types being related to the energy of it, yeah, in terms of a quantum of energy. Yeah, the smaller quantums of energy, no matter the intensity, you can shine lots of.
Let's just understand that photons are basically in atoms. They're held sort of like a spring. It's the pressure between the electrons. So you can understand that you can tighten the spring, and those would be higher frequency that you could release. So the more pressure you create in an electron, the more pressure you can release as a photon. So if the electron disappears, the spring is all there is, and so that's the photon leaving. So whatever the compression is inside the atom will dictate what the photon is produced by it. That's why each atom produces a different wavelength of light. It's because it's under a different pressure, because there's 5 electrons or 4 electrons or 3 in a certain shell, and that creates a different amount of pressure. And that's all that's dictating this, and that there's a limit to how much pressure an atom can make and stay together, and that limit is ultraviolet light. And in extraordinary cases you can create higher energy photons, but you only create them by pushing huge amounts of energy into the atom and getting it very hot. So you're pounding the electrons and you're pushing them deeper and deeper into the trampoline. I use that example. You're pushing them deeper and deeper into the trampoline so they can rebound out further and further. But that's not a common state of an atom. That's the uncommon state. And if you do too much of that, the atom itself breaks. But for creating light, the best way to create light is to have the atom in its natural state and create just a little bit of agitation, and then you'll get those tennis balls flying off the trampoline. All right, well, a little more.
High visible light at copper. Yeah, you can keep adding more and more lamps. That's the simple.
So again, this is shooting bullets analogy. So you can shoot all the bullets, you can shoot 1,000,000 bullets, but if you're shooting them slowly, in waves that are slow, like a bunch of bullets and then no bullets and a bunch of bullets and no bullets, the point is that you won't be able to push those tennis balls in before they bounce back out. They'll rebound before you hit them again. So you won't be able to make the extra pressure necessary to have that huge rebound. Another point I wanted to make is they also found with that experiment, though, that is, when they first did it, they didn't have a capacity to make laser beams and all that kind of stuff, so they couldn't use really high intensity light. And the fact is, if you use really high intensity red light, you can actually create these free electrons, with a little bit more regularity. So it's not like you can't do it with low energy light, with low frequency light. If you have it intense enough, you can do it, because actually what will happen is the one photon will hit it in, and then another photon will hit it further deeper. So if you have enough photons hitting it, then 2 different photons can hit the electron at the same time and push it deeper, and then the electron will be released. So again, it verifies the particle theory that the truth is that if you increase the intensity high enough, you can free the electrons. So anyway, enough. Maybe we'll do more of this sometime, but we'll see. I think all these experiments, the de Broglie, the Casimir effect, the Einstein's photoelectric effect, and the 2-slit experiments, these are all the foundations of quantum mechanics, and every single one of them has a rational, sensible, mechanical explanation that is available. And again, they just choose to go with the wacky photons have powers and magic powers Heisenberg explanation. This is a choice, not something dictated by necessity. They're not going there because they don't have any alternative explanation, or there's no possibility of an alternative explanation. They're just not interested in the alternative explanation. So, enough. Hopefully it recorded properly and such.